When you're ready.
Human genome editing has been at the forefront of scientific, social, and ethical conversations for years, especially since the creation of CRISPR-Cas9 technology. All of this controversy prompts the question, should we edit the human genome? Although there are many considerations to take in place, ultimately, yes, we should edit the human genome to advance medical research, but there are certain limitations we need to take in place in order to prevent unwanted heritable genetic conditions, which could cause long-term effects. Before we dive too deep into this question, we should give a little bit of background information first. So what is human genome editing? In simple terms, it is the altering of specific genes in the human genome, but its application is rarely that simple. One example of human genome editing technology is CRISPR-Cas9. This was developed after the observation of the abnormal repetition of the genome of a certain bacteria. CRISPR-Cas9 uses RNA to correct and change DNA sequences in the human genome. Scientists Emmanuel Charpentier and Jennifer Doudna first applied this phenomenon to human genome in their paper in 2012, which ultimately ended up winning them the Nobel Prize in Chemistry in 2020. Andrew Holland, the assistant professor in the Department of Molecular Biology and Genetics at Johns Hopkins School of Medicine, explained that Doudna and Charpentier showed that CRISPR works like a pair of scissors that can be targeted to cut specific DNA sequences. After cutting, the repair of the DNA code enables it to be altered. This has allowed scientists to change the DNA code in a targeted way to help understand and treat genetic disease. One application of this technology is in the medical perspective. Thanks to Ms. Rochard, we all know that sickle cell disease impacts the shape of red blood cells. These misshapen red blood cells can block capillaries, which can cause organ damage, pain, and even early death. And currently there is no long-term cure for this disease. Most treatments are currently focused on pain management and quality of life rather than a cure. And this was all true until about 50 years ago when the cause for SCD was discovered. It was a single mutation in the beta-globin gene, making this a perfect candidate for human genome editing. Adenine base editing, a specific type of CRISPR-Cas9, has been used with great success in the St. Jude in St. Jude in collaboration with Dr. David Liu of MIT. This has the potential to increase health and life expectancy for sickle cell patients by correcting this mutation. It is our responsibility to continue research into human genome editing to further the future of medicine and to help patients worldwide.
Genome editing is a topic of interest for scientists and the global community. Research and experimentation are being conducted at a rapid rate, yet social awareness is not being developed as quickly as is necessary for the social and cultural society to be able to fully support the concept of gene editing. I believe two key ideas are essential to expressing the social and cultural ideologies of human genome editing, or HGE: limitations and motivations. The limitations of HGE are crucial because of the constant advancements in technology. Social limitations are important when considering how the world will react to a new idea of genetic engineering. When we use the idea of genetic engineering in the sense of editing embryos and genes of future generations, we anticipate that with more experience and knowledge, we can use it to an advantage for future generations. There are many complexities in the relationship between genomes and the individual's well-being, so even if genome editing could ensure the child did not have the genetic variant associated with a particular disorder, the health of the future person could still not be guaranteed, states Nuffield Council. Society will not support uncertain research to edit the gene technology unless we have robust scientific support to back up the idea of genome editing will be safe and successful when looking into the long-term future. Medical limitations of human genome editing encompass things such as off-target effects, causing more issues within people rather than taking away the medical disabilities that they were trying to cure. Studies such as those conducted by Floor and Trypin showed that CRISPR-Cf1 has recently showed promise in diminishing the effects causing off-target results in people's genetics. CRISPR-Cf1 may overcome CRISPR-Cas9's few limitations that we have seen. Other researchers found a large number of unexpected mutations described as off-target effects, which means that the CRISPR-Cas9 system interfered with other regions in embryos of mice and humans, had a number of unwanted errors compared to other studies. These studies highlighted that we still are not fully confident in CRISPR-Cas9 technology. Public attitudes and opinions may evolve over time, possibly as a result of the way technology is introduced, taken up, or offered alongside existing information about CRISPR technology and the technology of human genome editing in itself. Policies for the use of genome editing for any particular purpose should be formed by public interests that are identified and understood through inclusive social debates before making any decisions to humanity that will not be supported by society.
Going back to our thesis, we believe that there should be limitations brought in place under genome therapy. This supports the fact that ethically, editing has negative impacts in the first place. The main topics I'm going to be discussing when it comes to ethics in genome editing is how it affects the current disabled population in a negative way, and also how editing is not being used in a useful way in less developed countries. Throughout history, people with disabilities have been discriminated against, which is known as ableism. According to Ethics of Human Genome Editing by B.S. Collar, even today, those with disabilities face constant bullying, unfair treatment, and in some cases, violence. Using gene therapy to give some people an advantage before they're born can make life harder for those with disabilities, especially people with mental disorders. It can make them feel lonelier, less confident, and worse in how they see themselves. Currently, some people see disabilities as a burden or difficulty that prevents full quality of life, including healthcare workers. Collar proposes that studies indicate that healthcare professionals tend to overestimate the impact of some disabilities on life satisfaction of children and their families. This shows that people with disabilities can still live happy and healthy lives, and gene therapy might take away our destined genes. Next, genome studies are very important for changing genes, but some people worry about these studies happening in poorer countries. In the article, Ethical Issues in Human Genomics Research in Developing Countries, DeVeris talks about how scientists study many diseases like skin, heart, and blood problems. But these studies don't help much with diseases that affect people in poor countries who want a better quality of life. For example, in places like Africa, Asia, and South America, diseases like malaria are getting worse. Diseases like this aren't studied enough and will get worse and worse for the generations to come. DeVeris states, substantial global inequalities exist in health measures such as morality, quality of life, and disease incidence. These persist despite increasing levels of overall wealth. This shows with all the money in the world, less developed countries aren't getting the research to stop diseases that kills millions of people. But a wide range of other illnesses are being heavily studied in places that aren't killing that many people, for example, America.
Hopefully you can see that human genome editing should be pursued, but we have to use caution and put limitations in place in order to avoid unwanted effects. Thank you.
All right, thanks. Harriet, describe an argument from one of your peers' individual reports that made you think differently about your solution or conclusion.
So Mandy's work or research in the effects it has on the disabled population most impacted, I think, our conclusion, because me and Raegan both talk a little bit about the positive effects, and Raegan also talks about negative, but mine is solely focused on positives. And I think that Mandy's adds the counter argument to mine, saying that no, we shouldn't, because disabilities aren't always disabilities.
Okay, thank you. And Raegan, reflecting on your colleagues' work, which one had the greatest impact on your overall understanding of the problem that the group identified?
I believe Mandy's lens expanded my understanding of the topic the most because of her genuine reflection of the long-term ethical effects of genome editing within other countries, and even including people we see every day who may have ideas about genetic engineering but thinking about the negative ethical effects that may be at hand.
Okay, thank you. Mandy, what is the way in which your team's resolution conclusion makes you think differently about your own individual research?
Our resolution makes me think differently about how ethics can be practical and successful in genome editing. This is because it would probably be very hard to apply rules to an already heavily conflicted and biased population, and it would be a big challenge to make decisions on ethics in the right way.
Okay, all right. Thank you. Another round of applause.